let's double check the consumption of bottled water. So the annual consumption of bottled water has been increasing since 1990, and here's the data. 1990, 2.2 gallons drank in the United States. That is 0 years since 1990. 1995, that's 5 years later, 3.1 billion. 10 years later, 4.7 billion gallons. 15 years later, 7.5 billion gallons. And 20 years after 1990, 11.4 billions of gallons drank. Make a scatter plot. Okay, back to this. Stat. Edit. Okay, I had a lot of lists. So I went ahead and put the years since 1990 in list 5 and the billions of gallons of water, bottled water drank in L6. So I'm going to go second stat plot, hit enter, turn on this, and now I'm using list 5 and I'm using list 6. But I also remember in the last problem, I had graphed this equation with it, so I have to clear it. Zoom statistics for number 9, and we get this image. Okay, so here is our image, and we're going to have to make a decision on whether we see curvature or not. I personally think that we do. I see a little bit right here curving up instead of it going like this. So now both of them I could see an argument for, but I see a little bit of curvature. So here we go. Make a scatter plot, label the axis. Always do. I believe that year is the explanatory, and I believe the billions of gallons of water drank, bottled water, is the responding variable. So this is years since 1990, billions of gallons drank of bottled water. Okay, and we saw something of the sort. So here, something like this, yes? And then it says, is a line or a quadratic more appropriate? This is a tough call. It really is a tough call. Tough call. And so here it says number 3, use your calculator to model using the quadratic. So it's almost like maybe we should check them both. Okay, here we go. So using the quadratic reg, right? Okay, back to stat, over to calculate, down to the quadratic regression. List 5 and list 6 is what I used. All right, I'm going to copy this. I'm going to go to the nearest, it would be nice if I could include this. So I'm going to go to the nearest tenths, hundredths, thousandths place, or 3 decimals. Okay, so for number 3, I would say, let's call this T, and let's call this gallons drank. So I would say gallons is approximately 0.021 T squared plus 0.045 T plus 2.249. Okay, so here's using the quadrag. Now, if we went to linear, I'm not sure what's best, but I do want to say that the r squared here I mean, look at how close that is. That is almost 100%. That is almost 100%. So we're going to compare that. We got 0.9996 for our r squared. Okay, so just so that we write this down, 0.9996 was the square of our correlation coefficient. Now, I'm going to go calculate the linear regression, and let's see what happens there. 0.933, so it's pretty good still. It would still get an A, you know, it's 96%, that's pretty good, but it's a little bit just not as good, right? So it has a little bit of curvature visually speaking. And so now that being said, so I'm gonna write this down, and the higher order your model is, the better it's gonna get, but r squared was approximately 0.933. Okay, so this is a little bit stronger, and with the linear equation, this would have read g is approximately 0.456t plus 1.22. Okay, because I'm going to use it in a minute. Use your graph to predict when the annual consumption will reach 14 billions of gallons of bottled water. Because I remember we have actually done this using the quadratic formula on our equation. So that means that G equals 14. Yeah? Okay, so if I'm using my graph, here's what I'm going to do. I'm going to put G into Y1, our model equation into Y1, and I'm going to put G14 into Y2, and I'm going to see where they meet. Okay, so let's go back. I'm going to do a couple of things now that I have all of this. So I'm going to go to Y equals, and we already have graphed our scatter plot. First, I'm going to go ahead and put in this linear equation, 0.456x plus 1.22, and I'm going to put in our quadratic, 0.021x squared plus 0.045x's, okay, plus 2.249. Okay, and I'm going to graph. So just so that we could visually see what was very subtle, that subtle curvature, sometimes it's worth it to put in the equations into Y1 and Y2 to actually test your eyes. Because perception, perception can be off a little bit. Our vision and our belief systems can sometimes be wrong, and then we fix and adapt and better ourselves. So the quadratic seems to actually fit very well with this slight amount of curvature. The line's pretty good. It's pretty darn good. But that curvature seems to fit it in a little bit nicer. So I'm going to go into Y equals. I'm going to clear the line. And then I'm going to actually put this into the first one. 0.021 x squared plus 0.045 x's plus 2.249, because I said I was going to put 14 into Y2. Got it. And then graph. So here's my quadratic model, and we do not see 14, so we're going to have to zoom out. Zoom out. There's our data, and here's a big sketch of our quadratic. Ooh, but there's 14. So it's outside of our data set. We're going to make an inference about what's happening at that point. So let's go second, calculate, find out where they meet. Where do they intersect? Okay, first curve is blue, second curve is red, and my guess, who cares? Okay. La-di-da. So this just solved our equation and found that the x value is about 22.6. Well, isn't that nice? So it said, so just to make a rough sketch of this, okay, we had something like that, and then we had a little bit of this, and here's where they met, and this said that the x value, this was at 14, and that said that x is approximately 22.6, which of course to us is a t value. So t is approximately 22.6, which means, what year is that? 1990, so second quit, 1990 plus 22.6 years in about there are 14 billion gallons consumed in the US. Okay, so now first, I want you to know that the model that we've been using up to this point was this, and it was based on this data. Okay, that was only 1, 2, 3, 4, 5 data points still. So it would be nice if we had a bigger sample, a little more tedious, but that's okay. And in addition to that, I want you to know that this intersect function, so we put our model into y1, we put our value of gallons into y2, and then we used our graph with the intersection function, so second calc intersect, in order to do in this problem what the quadratic formula did behind the scenes. Okay, so if we are using the equation, we follow these steps. Number 1, set it equal to 0, write down the ABC, put them into the formula, compute, do your either or, and then write down our answer. Whereas here, we put our model into y1, we put our what we're hoping for into y2, the value, and then we do second calculate intersect. You know, either way, it's good, and you need to be able to be flexible in your understanding, and know that your calculator actually does a lot of computations behind it. It's pretty fast too. So we use the calculator to find the best fitting quadratic model given our data, and then we solved problems and we interpreted those solutions in the context of the actual problem given to us or posed to us. So just don't forget that when you're solving quadratics, you might need to use the quadratic formula, especially when it comes to models that look pretty funky and can't be factored.